Doesn't give it. So this is my long way of saying we can anti-derive when it is a linear function subbed in, like into a chain rule or cosine or something like that. And what is a linear function? What is the form of a linear function? Ax plus b. So if you see something like this, 2x plus 3 or 7x plus 2, because the derivative is a constant, it makes it easier to work backwards when the derivative is a constant. So the derivative of 2x plus 3 is 2, and therefore working backwards isn't as difficult. So I'm going to do a bunch of these. We're going to apply this theory.
So is it possible to not do it if it's squared?
It is
Impossible
it is possible, but it is very difficult.
And we don't have to do that?
We'll have to do ones like that, but we'll have to do different methodology. Because you have to undo, like, it's like undoing a quotient rule is going to be pretty difficult, and undoing a lot of chain rule is pretty difficult. But if this is a notice all of these are including a linear function subbed in. So it's a composite function with a linear subbed in. This one you're thinking, okay, maybe not, but maybe in a second it will be. Anything else, you're saying that's not a linear, subbed into a... Now remember, 2x on its own is linear. Okay, so let's start to do some of these. So how do we integrate something like 2x plus 3? So immediately you think this looks a bit like the chain rule. So undoing a chain rule, which is what our starter is, or the previous thing was. How do I undo? We got this one right. So how do we undo it not knowing what the answer was already?
So you would keep the inside of the bracket?
Yeah, so we need that linear there.
Put it power 5?
Yes.
And then you would do like 5 times 2? It's not that.
It's, yeah. 1 over 10. Plus c, yes. So yeah, you could think of it, it's probably better off to think of it as like this if you're writing it down. So this is this number. Yes. And this is this number.
Is there a formula for that in the book or not?
Yeah, I'll show it to you in a second. I think it's better off, maybe it's better off to remember how to do it rather than going formulaic. Okay, this one then is 1 over root 1 minus, this looks a lot more difficult. Oh, good thinking.
Oh my gosh.
Look at tan though, look at tan.
It's not tan.
Yeah, it's x.
No, they also x squared. That's not x squared.
See, it has x squared in it, yeah, so I don't think tan has the x squared in it. So this one's not going to work for tan.
Don't they all have x squared?
Yeah, but this one doesn't. So I can't use that yet. So let's do the rewrite, like Derek was suggesting. 1 minus 3x to the power of negative a half. Can I apply something like I did here?
Yes.
1 minus 3x to the positive a half.
Yes. And then negative half over. It's
So,
negative
3
1.
by
It's
2.
negative.
3 by 2.
So I'd have to divide by negative 3, won't I?
Oh,
And then what about the half? I divide by a half, which is multiplying by 2, and plus c. Right. I'm not convinced by this one, so I will derive it just to make sure. So you have negative 2/3. Let's put this square root 1 minus 3x plus c is what we said, yeah? So I'm going to derive this one just to make sure. I'll just rewrite it as this again. Pretty pointless. Okay, chain rule now, our old friend. Multiply down by half, I get negative
2 by 6.
negative 1, 2, 6, 1/3, yeah, negative 1/3. 1 minus 3x to the negative a half, subtract 1, and then multiplied by what? To 1, and I get 1 over root 1 minus 3x. Yes, it does work. Hi.
Sir,
Yes.
what are the ways that you can write like the integral? Like, you know, when you do differentiation, you have like f dash x, and you have like d1 and dx. Like, what do you use, right?
This
Just
way.
like that's That's all, right?
Yeah,
There's no, like,
we'll
absolute-
talk, as I said before, we'll talk more about this when we get to the fundamental theorem of calculus, which explains this a little bit more, why that is. It's a sum, yeah, multiplied by little changes in x. But yeah, that's the one you're going to see.
There's
Yeah.
no, like,
Well, yes, if you see f dash x and you need to get back to the original function, you know you have to then use integration. Yeah. So that might come up. That's not written like that. Or you can see here, it could just be written. All right, let's do one with e to the x, and then I'll show you. I think you probably can figure out the formulaic method of doing this, but 2e to the 2x minus e to the minus 3x. Integrate that. Okay. What are we noticing? That every time we need to divide by, yeah, because this 2 and this 3 would end up being derived to 2 and 3, so I need to undo that deriving by dividing by that normally we end up multiplying by it when we're deriving. So to undo this multiply, we have to
so minus 1
divide.
6.
Oh, we'll come to it. So this first one, it'll be e to the 2x, 2, but I'll divide by something. What will I divide by?
4?
2.
Wait, but what about the 2 in the front? It'll,
The 2 next to the V
The-
is the 2 in front.
This 2 is from the original one.
but if you differentiate, wouldn't the 2 like change?
I'm integrating now.
So why isn't it 2x?
Okay, we'll come back.
2x
That's gone.
plus 1?
We'll come. Maybe it's wrong. There's there's an easy way to check if we think we're wrong. So maybe it's.
Minus negative 1.
Is it this?
Yeah.
Okay, so we are saying e to the negative 3x over 3 plus c will differentiate to get this.
Okay, yeah.
Right, so let's try it. What is the derivative of this? E to the 2x times 2 plus e to the negative 3x over 3 multiplied by negative 3, and the c will disappear. This will cancel with this, will turn this negative, so it is correct. Okay, let's look at the general rule, and then I'll come back to the other two. So the general rule, you probably figured out, that's not their questions, their answers to the questions. This is general rule. They always put the a here. It's always just 1 over a, whatever the integral is. 1 over a, and then integrate the outside function. Because the inside function derives to just a constant. And you got to undo that multiplication of a constant by dividing by it. So you're looking for this form. Notice that. Notice it's a linear subbed in. So if you see something, here's a few, sine 6x plus 3, something like that. If you've seen something like that, undo that, it'd be 1/6 negative cosine 6x plus 3 plus c. And then, yeah, 1 over that's another linear subbed in, a linear subbed in. Or even just something like that, like we just saw, that's a linear, it's plus 0, but it's a linear still. So all of those, you just divide by the number in front of the x. Divide by the number in front of the x, which is that what all those are summating to there. This one probably looks like the most complicated one, but it's actually the one we did first. It's like a little bit reverse chain rule. Add 1 to the power, divide by the new power, and then do 1 over. Okay? Let's go back and do a few more. They're yours, these are mine. Not going to do the middle one, the integrate 2 minus sine x. We'll do that together in a second. I just want to do one of the ones at the bottom first. So we'll do 1 over 5x minus 3 dx. Okay. Thoughts?
Move up.
Yeah, so what may happen in the exam is you might do something like this, the rewrite. Then you do what we did over there, add 1 to the power. 0. Divide by 0, and you go, uh-oh,
Oh, it's a linear.
and it's yes, ln. So this is like 1 over x, isn't it?
Why don't you just do UV substitution?
Because we haven't learned that yet.
Like for all of them.
Well, why would you do UV substitution if you can just divide by 5? So this would be ln 5x minus 3, 1/5. Okay, so just be wary of that one.
Wait,
No?
where's the one?
Is that wrong?
Oh, no, because you'd be multiplying by 5.
Yeah, when you,
Oh, I get it.
yeah. So if there's no power here, then it'll be ln, if it's just 1 over a linear. And now we look at the one in the middle, which I haven't done in 2 years, so let's figure out how to do it.
So just do what we did.
Yeah.
2 minus sine x equals 2 plus 1,000.
Thoughts?
Do what we knew was
Thoughts.
Expand it.
Expand it?
That's what I was.
Yeah, I probably would expand it too. Okay, so let's expand it and see. So that's going to be 4 minus 2 sine x, is it? Am I right? No, is it 4 sine x? 4 sine x? Sorry, 2 and 2 again. Plus sine squared x. Uh-oh. Why am I saying uh-oh?
Because you can't, it's not constant.
What's Aiden doing? He's frantic on his phone.
He's upset about his test, so he's redoing the last question.
Okay.
There's a non-linear thing. I mean,
Can we substitute an x of a?
With a?
Possible.
Ooh, and you're thinking like quadratic?
Yeah.
No, that's not going to work out for us, I don't think.
It was 3 points.
Because it's not a polynomial. It's not going to...
isn't it just
Why do we go back? I don't even know.
1 over 3 plus
Yes, yes, no.
But I didn't want to expand it. You can read it.
You didn't want to expand it? No expanding. Okay, good idea. Go backwards.
keep the two divided the same as the
Yeah, that's what I would.
Yes,
and then in the denominator, it's 3,
yes.
and then times cos x.
Oh, but this isn't linear though. This is not, like we're applying the linear rule to a non-linear. So times cos x, yeah? There's only one way to find out. Times cos x or divide by cos? Divide by cos x. You're falling into that trap again.
Oh, not very.
Because when I go to derive this, I'm going to be left with cos squared x in the denominator.
What does that mean?
I don't think that's going to work for me.
So then how do you get rid of it?
This. Go back to this. But I have, come on, tighten the trig.
So, oh, wouldn't it be
Stop.
wouldn't
That
it
identity.
be negative cos
I
x
didn't.
times negative cos x?
Sine squared x can be rewritten as a not squared somehow.
Square root minus, no.
Which one we go? Which one we go over here? Who has the formula booklet today?
Thank you.
Okay, you.
It's
Is it not Pythagorean?
It is.
Pythagorean.
So I know that
It's 1 minus
cos
cos
2x minus
cos.
1 over negative 2.
I know that this is true. That one. I've rearranged that one. Now I need it for sine. So how do I get that? Maybe if I swap these sides, 1 minus cosine 2x is equal to 2 sine squared x.
Okay, yeah.
1/2 minus 1/2 cosine 2x.
I need to revise my tricky yesterday.
All right, that is the same. Yeah?
Wait, Mr. Moore,
So I'd use it.
explain.
I'd use a trig identity.
Which one?
Yeah, the cosine 2 theta one probably up there. The last one says it's equal to 1 minus 2 sine. And now I have x sine squared x, but I want it on its own. So I rearranged it. I swapped the sides here, swapped these two over. And this sign stayed positive. Okay, and now I have this. And why I want this is linear now. 2x is linear. So I'm going to go 4 minus 4 sine x plus 1/2 minus 1/2 cosine 2x. I still haven't integrated it. Probably could put these two together. 4 plus 1/2 is? Yeah, but like in 9 over 2. 9 over 2 minus 4 sine x minus 1/2 cosine 2x. Now I'm ready to integrate finally. Oh, then yes.
Oh, I study either way because it's the end of.
Yeah, it'll be end of semester. It's on the end of semester. So.
Plus 4
Plus 4 cos
cos x.
x.
Minus 1 over 4.
Yes. Minus 1 over 4 sine 2x plus c. So I did 1 over a there. The 2 divides down. That's the linear bit. And this is my answer.
Would they ever ask you to do it in a way without UV substitution? Like do it this way? Yeah.
No, they won't tell you to do it this way, but this is probably the quickest way.
But like if you have that, if you did UV, it would be a less.
Oh, maybe in that case, yeah. No, they'll usually just say integrate, or it'll be part of a question